Hello students, welcome to my channel Sriram EduTalks. In today's class, we are going to learn how to prove the midpoint theorem. This theorem is in the chapter called Quadrilateral of class 9. The statement of the theorem states that the line segment joining the midpoints of two sides of a triangle is parallel to the third side. Now, we are given in this that D is the midpoint of side AB, whereas E is the midpoint of side AC, and we have to prove that DE is parallel to side BC. As you can see, I have drawn some part in red as well. Now that indicates this needs to be done as part of construction. So you need to remember that for proving the theorem, we need to do this construction as well. That is, through point C, I am going to draw a line which is parallel to side AB, and this is going to intersect the line DE produced at F. So draw a line through CF parallel to AB which intersect DE produced at F. Let us write down all these details, which is very important. So you need to write what is given. So we are given that AD equal to BD and AE equal to CE. And now you will write down what you need to show. So we need to show that DE is parallel to BC. And lastly, I will use a red pen to write down the construction part. What we need to do as part of construction. So through C, we are drawing a line parallel to AB intersecting DE, which is extended or produced to F. Okay, now let us start the proof. So first of all, I need to consider two triangles. Here I am going to consider this and this triangle and prove them to be congruent. So the triangles are AED and triangle CEF. Now I will prove these two triangles to be congruent first of all. So as we can see clearly, first of all I am given AE equal to CE. Then as we can see, this angle is equal to this, vertically opposite. So angle AED is equal to angle CEF, vertically opposite angles. And lastly, as I have constructed CF to be parallel to AB, so this angle and this angle becomes alternate interior angles, hence they are also equal. That is angle DAE is equal to angle FCE. In the bracket, you can write the reason: alternate interior angles. So the two triangles now become congruent by the rule angle side angle. Here also angle side angle. So therefore, triangle AED congruent to triangle CEF by the rule ASA. Now, immediately after that, I will write down by CPCT that DE equal to EF and AD equal to CF. Okay, so I have proved these two sides equal as well as AD and CF also to be equal. Next is, I already know that AD is given to be equal to BD, and just now I have written AD equal to CF. So that means your BD also become equal to CF. So AD equal to CF, AD equal to BD, that means both BD and CF are also equal. Also, by construction we had drawn AB parallel to CF and BD is a part of AB. So I can write BD parallel to CF, that is by construction. Now there is an important rule which says that if in a quadrilateral any one pair of opposite sides are both equal as well as parallel, then that quadrilateral is a parallelogram. So you can use this property here and write down this implies BDFC is a parallelogram. And you can state the rule as well here that if any one pair of opposite sides are both parallel and equal, then quadrilateral is parallelogram. So now this becomes a parallelogram. And we know that if BDCF is a parallelogram, then it's another pair of opposite sides, DF, also parallel to BC. So therefore, DF become parallel to BC. And you can see DE is a part of DF. So this would imply DE parallel to BC. So that is what we intended to prove, first of all, that DE parallel to BC. But students, the proof is a little beyond this, as in we can also show that DE, which is parallel to BC, is also equal to half of BC. Let's see how we can do this. So I have already drawn and proved that DE is parallel to BC. Now we know being opposite sides of parallelogram BC equal to DF, and as E is the midpoint of DF, which we have proved through congruency, so I can write DF as double of DE. I can write double of EF also, but I have written double of DE. If I take 2 to this side, I get DE equal to half of BC. So this is another aspect of midpoint theorem, that the line joining the midpoints of any two sides is not only parallel to the third side but is also equal to half of it. So that is all for the proof of this theorem. Hope you have understood the theorem very well. Now I request you to please subscribe to my channel, and also don't forget to tap the bell icon in order to get information about more such videos in the future. Thank you.